SimplyNano1 is a new nanotechnology experimental kit for students. It was developed by the Simply Science Foundation in cooperation with the Innovation Society St. Gallen. The SimplyNano1 experimental kit exists in 4 different variations: English, German, French and Russian. It contains 8 exciting experiments about nanotechnology. The topics: nanodimension, reactivity of nanoparticles, as well as nanosurfaces, are presented clearly and simple. Heinrich Rohrer received, 1986, together with his colleague Gerd Binning, the Nobel Prize in Physics for the invention of the scanning tunneling microscope. With this microscope, nanoscale structures can be made visible. The SimplyNano1 experimental kit contains a Lego model of a similar microscope. Heinrich Rohrer is the ambassador of the SimplyNano1 box. We have conducted an interview with him.
In the SimplyNano1 experimental kit there is a Lego model of an atomic force microscope. This is very similar to the microscope you invented. What do you think about this AFM Lego model?
Every descriptive model is very useful. The AFM Lego model is such a demonstration tool that helps to better understand. Learning in school means mainly understanding whatever is taught. Just learning by heart is by far not sufficient. Illustrative material like the Lego model is a great help for most people. Only very few can do with abstract thinking alone.
Why should a student in a secondary school be interested in nanotechnology?
Nano is a scale of nature. All fundamental processes of nature are running at the nanoscale. Molecules are able to recognize each other. Larger structures emerge from these molecules, but all of the native fundamental processes are nano processes.
Which role does playing have in a laboratory experiments?
A game can only be a game as long as its outcome is initially unknown. Investigating the unknown and researching the unknown has therefore always a considerable playful component. That is as important as endurance, persistence, and last but not least, hard work.
The SimplyNano1 experimental kit contains 8 experiments from 3 different topic areas. The topics: nanodimension, nanosurfaces, and reactivity of nanoparticles are presented clearly and simple. With the Lego model, it is possible to show the operating mode of an atomic force microscope. The sample surface is pulled under the sensor, and you can see how the laser point moves on the scale according to the surface. The data can be transferred to an Excel program, and in the Excel program is a graphical representation of the surface analyzed. The three-dimensional model shows a graphical representation of the examined surface. The values can be presented in an 8x8 matrix. The nanometer scale shows the magnitudes of the nanoscale and the associated biological and technological structures. The task is to arrange the structures according to their size along the nanometer scale. The lotus effect is an important phenomenon in the world of nanotechnology. In the SimplyNano1 experimental kit, lotus leaves of the Asian lotus plant are included. If liquid droplets get on the leaf's surface, it is possible to observe this water repellence effect. If dust or sand comes to the surface, this is entrained by the water drops. This leads to the self-cleaning effect of the lotus leaf surface. The lotus effect can also be demonstrated on technical surfaces, for example on metal. If you produce a layer of soot with a candle flame on a spoon and then sprinkle it with water, you can see that the water droplets roll off the black surface. It is also possible to show the lotus effect on a glass surface. By producing a sooty layer on glass with a candle flame and sprinkling the sooty surface with water, a similar effect to the one with the metal or the lotus leaf can be observed. The lotus effect can also be shown on textiles. You have to impregnate a textile with a nanorepel spray and let it dry. If the two samples are sprinkled with water, the lotus effect can be observed on the surface. The surface-to-volume ratio can be demonstrated and calculated with the wood cubes as a function of the size of the material. Until now, there are no teaching materials for nanotechnology for high school students. The SimplyNano1 experimental kit for nanotechnology offers for the first time a practical teaching tool for high school students. The teaching training courses were conducted for the first time in spring 2012. These courses offer interested teachers the opportunity to carry out the experiments of the experimental kit and thereby learn the basics of nanotechnology. As part of the training courses, the teachers get familiar with the phenomena and receive a SimplyNano1 experimental kit for free. The courses were a great success and were attended by many teachers. So far, 850 SimplyNano1 kits were produced and more than 40 courses were held up to now. Courses are offered regularly. For further information, please contact the Innovation Society St. Gallen.